In this video, I'm going to walk you through assembling and analyzing data from Ion Torrent using SeqManEngine. For this project, we'll be using E. coli data and assembling it against a reference genome. So the first step after launching the program is to select your project type. So I'm going to keep the selection of genome assembly and click Next. And then it asks me for my assembly type. And I'm going to select templated assembly small genome since we're using E. coli, and then click Next. Here I need to define my project name, so I'll go ahead and type that in. And I also need to specify a project folder, which is where my output files will be saved. And I already have a folder set up for that purpose. And then you'll notice that I have a few different options for how I want to save my project. By default, a SeqMan project file is generated, and I'm going to keep that selection. But one other format I want to point out is the BAM format, which will generate a BAM file that is not editable. However, when you use that format, SeqManEngine will use Bayesian statistics to calculate your SNPs, and you can then view and filter on those statistics in the SNP report. But for now, I'm going to stay with the SeqMan project file and click Next. And then I need to specify my template sequence, which I have saved locally. And click Next. And here I'm asked to specify my sequence files. So I'll select Ion Torrent from the Read Technology field. And then I can select the 3 SFF files that I have from Ion Torrent that contain my reads. Then I can click Next. This page is for adjusting parameters related to trimming my reads, and I'm going to leave the default settings here as they are and click Next. This page allows me to adjust assembly parameters. However, based on the project and assembly type we chose earlier, as well as the read technology we selected, SeqManEngine has already optimized these parameters for me, specifically for a reference-guided assembly of a small genome using Ion Torrent data. So although I have the option to adjust any of these parameters, I'm going to leave them as they are and click Next. And that's all that's necessary for setting up the project. The final step is to click Assemble, and SeqManEngine will begin assembling our data. Once the assembly is complete, it will automatically be opened in SeqMan Pro for analysis. The first thing you'll see here is the project window, which shows the config that was created from the assembly, as well as the length of the config and the number of sequences within it. From here, you can view the assembly at the nucleotide level by double-clicking on the config name to display it in the alignment view. From here, you can also view features, and because our reference sequence was already annotated, we can click on this little triangle here next to the reference sequence name to see its annotations. You can also take any of these features from the reference and use them to annotate your consensus sequence. To do that, select Features, Show Feature Table, and then select the features that you want to add. I'm going to select them all, and then choose Features, Copy Selected to Consensus. And that will open up the feature table for the consensus sequence and show me all of the features that I just added. Now, to see a graphical representation of the assembly, you can access the Strategy view by selecting Config, Strategy View. Here you can see the features on the consensus that we just added from the reference sequence. And you can also view the depth of coverage for the assembly, which looks very consistent throughout the config of right around 20x. Now there's also a depth of coverage report you can access, which gives you a summary of the coverage for the current config. And you can find that by selecting Config, Coverage Report. And you can also save this report as a delimited text file if you choose to do so by selecting File, Save Coverage Report. To analyze SNPs in the assembly, select SNP, SNP Report, and SeqMan will generate the SNP report for you. Now notice that there are approximately 278,000 SNPs found, so you may want to narrow your results, and you can do that by using one of the SNP filters available at the top of the SNP report window. For example, you can filter by the min and max percent SNP values, which refers to the percentage of SNP bases in the aligned column. For example, I'm going to change the minimum value to 75, and that narrowed my results down to 320 SNPs. You can also choose to show only SNPs that meet a certain depth of coverage by using the depth filter, or only show SNPs that occur within the maximum specified distance from any exon or CDS feature on the reference. As you scroll through the SNP report to review the putative SNPs, notice that the SNP is highlighted in the alignment view at the same time, so you can view the SNP within the context of your assembly. You can also reject or confirm SNPs as you go by using these options from the SNP menu. Any SNPs that you confirm will automatically be annotated as variation features when you save or export your consensus. If you have further questions about assembling or analyzing ion torrent data using SeqManEngine, please visit our website at DNASTAR.com or contact us at support@DNASTAR.com.